Okay, so today we are going to be talking about the mole and doing some introduction notes over the mole.
Yes, nice to know you. Meet you. Nice to meet you, Mo. Don't say Mo.
That's silly. Okay, so the mole is basically the unit for the amount of matter that a substance or a sample contains. And the abbreviation for mole is MOL. It's quite the abbreviation, only taking off the E. But you'll see Herzog and myself writing MOL pretty much the entire time. Okay, so the mole is a number just like any other amount that we have seen. So you guys are used to hearing 1 dozen, which is 12, or 1 pair, which is 2. Well, 1 mole is 6.02 times 10 to the 23rd of whatever it is that we're talking about. Okay, and we'll do some examples with the mole a little bit later. All right, we call this Avogadro's number. Okay, the 6.02 times 10 to the 23rd is called Avogadro's number. Not avocado, but Avogadro. All right, and we haven't practiced doing scientific notation in our calculators for a while, so I'm going to show you once again how to put this into your calculator. So type in the 6.02, and instead of times 10, make sure that you hit the second button, followed by the x to the minus 1 button, and remember above that button is that double E, that EE. Okay, so that whole thing right there is the same as times 10. All right, so then the last thing that you have to do is just punch in your exponent, which in this case is 23. All right, so just a quick refresher on how to punch in the numbers into scientific notation.
Now, the one thing you need to know is on your calculator, this is how it's going to show. All right, even though it's an EE here, your calculator looks like this: 6.02. It's going to show an E23. All right, just kind of know that's what your calculator will look like when you do this. Even though it's EE, your calculator will only put E, so don't do this twice. Just do it one time. Second, and this button right here, if you have a Texas Instrument calculator like we do in class, it's above the 7.
All right, so that E right down here is the same thing as times 10. Okay? All right, so 1 mole of carbon atoms, like we talked about before, is going to be equal to 6.02 times 10 to the 23rd carbon atoms. Just like 1 dozen carbon atoms would be 12 carbon atoms. Okay? And then 1 mole of water molecules would also be equal to 6.02 times 10 to the 23rd water molecules. So it's the same as saying a dozen or a pair, just like we talked about before. So not too complicated. All right, in chemistry, we're basically going to use the mole to measure what are called representative particles. Okay, representative particles are so small that we actually can't get instruments to measure or count how many of them that there are. Okay, some of the representative particles that we'll be dealing with include things like atoms, molecules. I had kind of a brain fart there for a second. Ionic formulas.
This is formula units.
Which is actually formula units.
So it's the same thing.
But it's the same thing, so.
Ions.
Not to worry. And then finally, ions. All right, so those are our representative particles. The ones that we're going to be using most often are going to be atoms and molecules. All right, every once in a while, formula units, every once in a while, ions, but basically atoms and molecules. Okay, so how do we convert between representative particles and moles and representative particles? Okay, well, if you remember back to when we first did conversion factors, you should remember that a conversion factor consists of 2 measurements that are equal to each other. Okay, and the 2 measurements that we're talking about here is that 1 mole is equal to 6.02 times 10 to the 23rd representative particles. Okay, so we can actually take those equivalent measurements and turn them into conversion factors. All right, so we can do 1 mole over 6.02 times 10 to the 23rd representative particles. Or we can do 6.02 times 10 to the 23rd representative particles over 1 mole. So either one of those will work, but not for every problem. Okay, so let's take a look at an example problem. So how many moles of magnesium is 1.25 times 10 to the 23rd atoms of magnesium? Okay, so we're going to start off by writing down our known information. All right, so right now we know that we have 1.25 times 10, that was awful, to the 23rd atoms. And what we should remember is that atoms were one of our representative particles. Okay, so we can use our conversion factor for moles to representative particles. That's a terrible line. All right, so if atoms or representative particles are on top, okay, if it's what we start with, remember that that has to go on the bottom. So atoms will go on the bottom, and then what we're converting to, which is how many moles, that will go on top. Okay, and then all we have to do is, which conversion factor we're going to use? Well, that's going to be this one, the one with moles on top. All right, so we'll put the 1 mole on top. We'll put the 6.02 times 10 to the 23rd on the bottom. And then all we have to do is the math. All right, so it's 1.25 times 10 to the 23rd times 1, which ends up being the same thing, divided by 6.02 times 10 to the 23rd. All right, and if you punch that into your calculator correctly, you should get 0.20764 and more. All right, so now we have to round according to significant figures. So our measurement has 3 significant figures. Remember, you don't count the times 10 to the 23rd, only the coefficient. So that's 3 significant figures. So we're going to cut that off right here. There's our 3 significant figures. And the 6 tells us that we're going to have to round up. So we end up with 0.208. All right, now we have to figure out our units. The atoms cancel out. The only units that are left are mole. All right, so that is our answer. So example number 2. How many atoms are in 2.50 moles of glucose? All right, so this one's going to be a little bit tricky, so make sure you pay attention. All right, so we write down what we know, 2.50 moles, okay, of C6H12O6. All right, you don't need to include that part if you don't want to. I usually do out of habit. Okay? Now, something a little tricky here. C6H12O6 is a molecule. Okay? So when we're doing our conversion, all right, we start with moles on the bottom because that is what's on top, what we've started with. But in our conversion, we have to put molecules on top because that is the representative particle for C6H12O6. Okay, so that's 1 mole. All right, we're going to use the other conversion factor. If you go back and take a look. All right, we'll go back here. All right, so we're going to have to use this conversion factor right here. Okay, so we'll put on our 6.02 times 10 to the 23rd. Okay, now if we cancel out our units, we're going to cancel out the moles. And what do we have left? We have molecules. All right, and that's not what we're trying to find. If you go back and take a look at our example, if you read our problem tells us that we need to find atoms. Okay, so we're going to have to do a second conversion. All right, in which molecules are going to be on bottom and atoms are going to be on top. Okay, and the easiest way to do this is to think about, okay, if I have 1 molecule, how many atoms do I have in that 1 molecule? Well, remember that our subscripts here stand for number of atoms. So if we add those together, we should get the number of atoms in 1 molecule. And that should be 24. So now we can cancel out the molecules, and we're left with atoms, which is what we're trying to find, so we don't need another conversion factor. So we go through, we do the math, and it should come out to an answer of 3.61 times 10 to the 25th atoms. Okay, just remember one thing that I kind of forgot to mention is that since these numbers are all on top of their conversion factors, we're just going to multiply all the way across. Okay, so 2.50 times 6.02 times 10 to the 23rd times 24. All right, so the last thing that I want you to do is in your books on page 311, I'd like you to complete numbers 5 and 6 for class tomorrow.
Oh, that's nice looking.
The end.